As said before, we will be now looking at some properties of general triangles. Let's start with the law of the sines. For the law of the sines, we assume that we have a triangle, any triangle, like this, and we will be naming the different parts. So we have a side A, a side B, and a side C, and we have an angle alpha, an angle beta, and the angle gamma. What the law of sines then tells us is that if we look at the sine of alpha divided by the opposite side, sine alpha divided by A, is equal to sine of beta divided by B is equal to the sine of gamma divided by C. So if we divide the sine of the angle by the length of the opposite side, then that fraction is a constant. So how to prove this? First, draw the height. So in this sense, add the height to the triangle, so the h, and we see that this height makes two right-angled triangles. So we can use the previous properties that we know. So in this case, what it means is that if we look at sine of alpha is then the opposite, h, divided by the hypotenuse b, and similarly, sine of beta is the opposite, which is h again, divided by the hypotenuse a. So if we combine them, so we bring here h is b times sine alpha. The other one gives me h is a times sine beta. So it means that a times sine beta is equal to b times sine alpha, or if we divide out, sine alpha divided by a is equal to sine beta divided by b. We now have half of the formula, and we still need to add sine gamma divided by c. So the reasoning is the same, but you will have to draw another perpendicular line. So the h that we chose first will not do, and what we will do is we'll draw a perpendicular line on one of the other sides. Doesn't matter which one, but we will be taking this. So here, draw a perpendicular line like this. So here we have a right angle. Call this one K, and now we can do the same thing. We now again have two right-angled triangles. One of them is obvious. For the obvious one, we see that the sine of beta is the opposite, in this case K, divided by the hypotenuse. So the hypotenuse for this triangle, here, this triangle, the one that I am pointing at, the hypotenuse for that one is C. So sine beta is K divided by C. For the other triangle, we have to think outside the box. So we have to think outside of the original triangle, and it's this one, so the one I am coloring now. So this triangle also involves K. So the angle in this triangle that we will be using is the angle here, which equals pi minus gamma. And so then we see that the sine of pi minus gamma is the opposite, so it's K divided by the adjacent, which is B. Furthermore, we know that psi of pi minus gamma equals sine of gamma. And thus from this one, we find that sine beta divided by B equals sine gamma divided by C. And thus combining those two results, we get the final result, the law of sines. When can we apply the law of sines? So when is it useful? It is useful if we know either two angles and a side and we want to know another side, or if we know two sides and one angle and we want to know something about the last angle. So it's always two sides and one angle, or two angles and one side that we need. For example, we have a triangle. Let's say the angle alpha is 20 degrees. The angle gamma is 25 degrees. We know the side C is equal to 80.4. The question now is, what are the sides A and B? So calculate these using the law of sines. The first thing we do is find the angle beta. So we know beta is 180 degrees minus 20 degrees minus 25 degrees. So beta equals 135 degrees. We can then apply the law of sines. So the only one for which we know both the side and the angle is the combination gamma with c. So we know sine of gamma divided by c is on the one hand equal to sine of alpha divided by a, and also equal to sine of beta divided by b. If we plug in for alpha and gamma, then we get the sine of 20 degrees divided by a is equal to the sine of 25 degrees divided by c, which is 80.4. On the other side, we see that the sine of 25 degrees divided by 80.4 is equal to the sine of beta, so the sine of 135 degrees divided by b. And then if we work this out, we can easily calculate a and b, which gives that a is approximately equal to 65 and b is approximately equal to 134. In the case of the law of sines, you also have to watch out for ambiguous cases. So be careful there. And we will give you some examples of what I mean with ambiguous cases. I will illustrate them by practical examples. So take a triangle. A triangle where we have alpha equal to 45 degrees. We have the side C equal to 7 and the side A equal to 7 times the square root of 2. Then what would be the angle gamma over here? So we use the law of sines, which gives us that we get sine of alpha divided by A is sine of gamma divided by C. Or if we plug it in, sine of 45 degrees, square root of 2 divided by 2, over A, which is 7 times the square root of 2, equal to the sine of gamma divided by 7. If we simplify, we see that sine of gamma is equal to 1/2. When now is sine of gamma equal to 1/2? Sine of gamma is equal to 1/2 if gamma is equal to 30 degrees or gamma is equal to 150 degrees. So we see we have two possible solutions here. Two solutions which are theoretically possible, but are they also possible in reality? So how to check? We know that the sum of the angles in a triangle is always 180 degrees. So is it possible to have an angle of 150 degrees in this triangle? So let's say gamma is 150 degrees. We know alpha is 45 degrees. That means that beta is 180 degrees minus 150 minus 45 degrees, which is minus 15 degrees. So it means that we would have a negative angle in a triangle, which is impossible. So it means that also this angle, this value for gamma, is not a valid angle in a triangle, and the only solution we have is gamma equal to 30 degrees. What now if we have a triangle with a side A equal to 26, a side C equal to 15, and the angle gamma equal to 29 degrees? In that case, again, law of sines, so sine of alpha divided by A is sine of gamma divided by C, meaning that we have the sine of alpha divided by 26 is equal to the sine of 29 degrees divided by 15. And the sine alpha is approximately 0.84. If we then look at the values for alpha, we find that alpha is either 57 degrees or alpha is 123 degrees. Which one is now the correct one? So what we have to do is we have to verify if they are possible, yes or no. If alpha is 57 degrees, that would mean that beta equals 94 degrees. And then we get sine beta over b equals sine alpha over a. And the side b is approximately 31. On the other hand, if alpha is equal to 120 degrees, it would mean that beta is approximately 28 degrees and the side b is approximately 15. So in this case, we see that both solutions are possible. And then a third example. Take again a triangle where alpha is 42 degrees, the side A is equal to 70, and we know further that the side B is equal to 112. In this case, using the law of sines, we get sine of alpha over A is sine of beta over B, or sine of beta is approximately 1.07. 1.07 is not possible because a sine is always between -1 and 1. So since the sine can never be larger than 1, the angle beta will not exist and there is no solution in this case. So depending on the case, you will find either one solution, two solutions, or no solution. And it's important to always verify that if you find something, that this solution that you found is also valid. So check that it is possible to find this solution.